Alright, let's in this video continue our introduction to the exponential decay model and come up with a general form in base E that we'll be using for exponential decay. This is a setup similar to the previous video, but I've changed the initial amount to 40 grams, and we want to see what effect that has on the model that we came up in the previous video. If we recall, in the previous video we started with 1 gram, and the model that we used in base E was, A of t equal to e to the negative 0.6931 t. Right, that was with an initial amount of 1 gram. Let's see what happens when we start with 40. Put the amount on the vertical axis, the time in years on the horizontal, and when t is equal to 0, we're going to have 40 grams. After 1 year, that amount will be cut in half, so it'll be down to 20 grams. After 2 years, this amount will be cut down half, giving us the 0.210. And after the 3rd year, 10 grams will be cut in half to 5. So given these conditions, the model for the exponential decay passes through these points, and much like the discussion in exponential growth, this model here is similar to this model, except all the y values have been multiplied by 40. All the y values have been multiplied by our initial amount. So the appropriate model for this graph and for this situation is going to be A of t equal to 40 times e to the negative 0.6931 t. Very similar to our progression with exponential growth. And so in general, when we talk about exponential decay, we will be using the formula A of t equal to a sub 0 e to the kt, or negative kt. Just remember that this number that we're going to be multiplying t by, since we're talking about exponential decay, is going to turn up negative. The a sub 0 is the initial amount. The k is going to be the relative decay rate.